Hi everyone, how are you? Hope you are doing well. Welcome back to another section. Today we are going to learn a new chapter, Understanding Quadrilateral. This is our third chapter. So in this chapter we are going to learn more about the quadrilaterals, different kinds of quadrilateral, its properties and so on. So before entering deep into this chapter, we should know some basics regarding this topic. Okay, so let us move to those concepts. Here are some key points. So here the first one, what is line, what is point, what is simple curve, and what is closed curve and simple closed curve. So these things we should know before entering this chapter. So first of all, let us think about a plane surface. What is plane surface? Yes, it is very simple. It is actually we can say in our real life, daily life, that the top of the table, it is a plane surface, or symbol that it's a blackboard. We can say that is a plane surface. So here the first one is the plane surface is clear. I hope it's clear for you. The second one, what is a point? So when we are keeping a dots here, yes, in a plane surface, we know it's a point, right? It's very simple. This much only you need to understand right now. So next one is what is lines. We know it's already familiar to us what is line and line segments. When we are drawing something, a curve like that, so it is extended to both directions, so we can say it's a line. Okay, when we are drawing a symbol, see here it is like this, we can say it's a line segment. What is a line segment? Yes, it is a part of line. Now next, it is already familiar to you, these things. Now it's a simple curve. What is a curve? First of all, in maths, the curve is just like when we draw something like this, it is a curve. When we draw like this straight line, it's also treated as a curve, right? And when we're doing like this, it's also a curve, right? And what about its symbol? The term comes the symbol. So what is symbol? When we are drawing some curves, it's do not cross itself. At that time, it's a symbol. So let us consider some examples, right? So when I'm drawing something like this, yes, it is a simple curve. So when I'm drawing something like this, yes, we can say it's a simple curve. But I'm drawing like this, we cannot say it's a simple curve. Why? It's crossed itself. So it is not a simple curve. And now what about this? This is also a curve, but it is not simple. Why? The reason is this one, it's crossed itself. So I hope you got the concept. What is simple curve? So simple curve means a curve which do not cross itself. That is simple curve. It's clear for you, I think. Now next one is what is simple closed or closed curve. As closed curve, it's simple this much only. When we are drawing something where we are starting, we are ending there itself, so we can say it's a closed, right? So when we are drawing a simple circle, we can say it's a closed curve, and also it's a simple closed curve. Okay, it started from where it ends, or its end from where it starts, so we can say it's a simple closed curve. When what we are drawing like that, it's not simple curve, right? Now come to the next point. Okay, what is line segment? We know that already we discussed the line segment. It's a part of line. It has a definite length. It has a fixed length. It's a part of line. So it's a line segment. Now why? See, here are some pictures. See, we have to match this one. So first one, see, simple closed curve is the closed curve that is not simple. It is the simple curve that is not closed and not simple curve. Some cases are there. So it's a not simple curve. We can say which one is not simple curve? Yeah, we can say it's a not simple curve. The reason is what? It's crossed itself, so we can say it's not simple curve. So another one is simple closed curve. Yes, we can cross like that. It is the circle, it is a symbol as well as it is closed, so we can say it's a simple closed curve. The next one is closed curve that is not simple, closed curve that is not simple, so we can say, see, it's not closed. See, here it is. What we can say, it is a curve which is closed, but it's not simple. Why? Yeah, it is actually like this. Well, it is its end where it start from, so we can say it is closed. Well, but it's not simple. The reason is that it's closed itself here, so we can say closed, that is not simple, this is here. Then which one is left? Simple curve, that is not closed. Simple curve, that is not closed. Yes, we can match it like this way. So here the curve, this one like this, it is simple curve, right? But it's not closed. Yeah, so this I hope this things it's clear for you. Yes students, why we have learned these things, what is simple curve and what is simple closed curves? Because to learn these things, polygons. What is polygon? Poly means we know it's many, so polygon, that means gon means sides, polygon many sided figures, right? So how we can define the polygon? Yes, it is here the definition. A simple closed curve made up of only line segment is called a polygon. So when we talk about polygon, we can say it's a simple closed curve which is only made up of only line segment. So it should be simple closed, made up of line segments only. So see here, we can say when we draw like this, it's okay, we know it's a triangle, we can simply say it's all made up of line segment, right? It's all simple closed curve made up of line segment, so we can say triangle, it's a three-sided polygon. Okay, so when we talk about this quadrilateral, we can say, see here it's a square or rectangle, something like that. We can say it's also a simple closed curve made up of line segment only. So we can say it is what? It is a four-sided polygon, right? Simple. Another definition of rectangle, that is four-sided polygon, right? And now when we talk about the figure like this, yeah, it is closed simple, but it is not made up of line segment. Here there is a line segment, but here it's not line segment, we know. So we can, when we cannot include this in this group of polygon, right? So the next one is here we have some curves that are polygon, curves that are not polygons. Well, it is very clear that, see here, the curves are polygon, because say yes, we have to check whether it's made a line segment only, and also it's simple closed, it should be simple curve and should be closed curves. Yes, all these three things are satisfying that definition, so we can say these are that are polygons, right? So what about here? We know these are not polygon. The reason is, see the first figure, it's just like this. So why it is closed here? But it is not simple, it's made up of line segment only, but it is not simple by it's closed itself here, so it's not polygon. So what about here? Yeah, it is closed, but what is the reason? The reason is here it is closed itself, so it's not a simple curve, because it's closed itself, so it is not a polygon. And what about this case? It's drawn like this. Yeah, it is made up of line segments only, but it's not a polygon. It does not belong to that category. The reason is that it is not closed. So the polygon definition is it should be a simple closed curve made up of line segments only. Well, now come to some classification of polygon, right? The first, you know already, just now only we discussed the classification of polygon on the basis of its sides. It's very simple, so we can say the number of sides 3, so that is categorized as triangles. So, and another definition of a triangle is that it's a three-sided polygon. Yeah, so what is triangle? Someone is asking, define the triangle. We can define like it is a three-sided polygon. So what about in the case of quadrilateral? Yes, that is our chapter name. So quadrilateral, we can define it as it's very simple, it's a four-sided polygon. So nothing to say more, we can say what is, someone is asking to us what is quadrilateral, we can just define it is a four-sided polygon, right? Maybe it is a rectangle, or it is a, what we can say, parallelogram, kite, something like that. Okay, the condition is this much only. The quadrilateral means it's a four-sided polygon. So what about five-sided polygon? Yes, we can say it's as pentagon, right? It should have five sides. And what about in the case of six-sided? It's a hexagon. Hexagon, we can define it as a six-sided polygon. What about in the case of heptagon? So we can say heptagon, it is seven-sided polygon. And what about eight-sided polygon? it is octagon, right? And 9-sided again and decagon, 10-sided polygon. So I like that we can generalize that a polygon with n-sided, n-gon, that means what? N-sided polygon, and so on, right? Well, now see, this term is already familiar to us, what? The diagonals. When we talk about polynomial, when we talk about that polygons, yes, there is a term diagonals. What is diagonals? It is a line segment connecting two non-consecutive vertices of a polygon. Yes, here we can consider a polygon. Yes, it's familiar to us, it's a triangle. So what about its diagonal? So it should be a line segment connecting two non-consecutive vertices. See here, it's we know that it's a vertices A, and here it's a vertices B, here it's a vertices C. So when we talk about these vertices, we know what about consecutive? Well, nearby, right? So when we talk about B vertices is consecutive to A and C is consecutive to C. So here we cannot find out two vertices which are non-consecutives. When we take the B vertices, we know this and this is consecutive, right? Nearby. Consecutive means nearby. So we can conclude that in a triangle we cannot draw a diagonal, right? Now come to the next, a quadrilateral. So here we can draw the quadrilateral. Maybe it is a rectangle or something like that. It's okay, it's a quadrilateral, four-sided polygon, right? So what about here the diagonals? Yes, here it's a vertices A, B, C, D. So here diagonals means it is the line segment which connecting two non-consecutive vertices. Yes, we can take this vertex and this vertex, right? So it is non-consecutive vertices. So we can draw one diagonal like this. Okay, as per the definitions. Well, it is the line segment which is connecting two non-consecutive vertices, vertex. Well, so is there any more diagonals? Yes, we can see here when we taking in this vertex is D, we can draw a line segment like this way. Yes, here is another diagonal which connect these non-consecutive vertices, right? Is there any other diagonals? No, there is. You're right. There is no other diagonals here. When we talk about that, when we consider the quadrilateral, there are only two diagonals. So it is only possible to draw. Well, the next, the term interior and exterior. Okay, in that word itself, that meaning is there. Here it's figures. You see, interior means something it is inside. When we consider a closed figure, it's okay. We can say interior part, interior portion. Yes, it is interior. When we consider, see, here is a point. A figure is here. Exterior means something outside. Interior means something. Some points which we draw inside. We can say that point is interior or exterior. Yes, this concept is clear for you, I think. Here is another concept that in the case of polygon, we can categorize this as in two categories, two groups. As the first one is convex and another one is concave polygon. Okay, in the case of convex polygon, it says what, when we draw a diagonals, it is passing through only the interior part, then we can say that is a convex polygon. And what about in the case of concave polygon? When we draw a diagonal, if it is passed through the exterior portion, then we can say it's a concave polygon. That is the definition of that convex and concave polygon. Anyhow, let us see some examples. So here is an example. Here is an example of a convex polygon. See here, we can draw here a convex polygon. Yes, when we draw a diagonal, it's like this. It's okay, only pass through the interior portion, and one more diagonal we can draw is it's passed through only the interior portion. Well, see here, from here we can take any picture, just like this. First picture is, it is like this. Okay, it is like this, a polygon, right? A, B, C, D. When we draw a diagonal, just we consider the vertices B and D. When we draw a diagonal, it is like that. See here, the diagonal BD, it is passed through the exterior portion. So we can say it is an example of concave polygon. So it is very simple. When we comparing this convex and concave, we can easily find out concave is something like that. Its vertex is something, it goes inside of that shapes, right? So, and its definition is this much only. When we draw a diagonal, if it is passed through the exterior portion, so we can say it's a concave polygon. And when we draw a diagonals, it passes only through interior portions. So we can say that is what it's a convex polygons. Well, next. Yes, next concept what we are going to discuss is that regular and irregular polygons. So regular polygon means what? A regular polygon is both equiangular and equilateral. Equiangular, that means when we consider a polygon, its all angles are equal and also all sides are equal. We can say it is a regular polygon. And an example of a regular polygon is, yes, you're right, that square. Okay, a square, when we talk about square, it's all angles 90 degree, we know. Well, and what about all sides? All sides are equal. So we can say it is equiangular and equilateral. Equilateral means side. All sides are equal and also all angles are equal. So it is an example of a regular polygon. Yes, can you see any other example of regular polygon? Yes, you said it. That is what? The triangle. In the case of triangle, equilateral triangles. So we can say not all triangles, but equilateral triangle, we can say this is an example of a regular polygon because all sides are equal. In the case of equilateral triangle, all sides are equal. It's equilateral and also equiangular because all angles we know it's a 60 degree, right? 60 degree angle in the case of equilateral. So all angles are equal and all sides are equal. So it's another example of regular polygons. And irregular polygon, it is not satisfying those conditions. So we can say all those categories belong to irregular polygon. So regular polygon means not only with these two example, we can say 5-sided regular polygons. Okay, there is no particular names. It's called, it's simply called what? See, this equal to this equal to this equal to this equal to this side. So and this angle equal to this angle equal to this angle equal to this angle equal to this angle. So we can say this is 1, 2, 3, 4, 5 side regular. It is a regular. It is a regular pentagon, we can say. It is just like that. So regular polygon means only two things we have to note. It should be equiangular and equilaterals. Irregular means it does not satisfy those conditions. Example, equilateral triangle, a square. These are the examples of a regular polygon. And what about in the case of rectangle, something like these shapes? Yes, we know opposite sides are equal, well, but all sides are not equal. So we can say this is an example of irregular polygon. So example of regular polygon, square and equilateral triangle. Now come to another sections. Yes, what is that? Angle sum property of a triangles. We know when we talk when we consider a triangle, it has three sides, it has three angles. So what about in the case of some of these three angles? We have already learned in our previous chapter, previous classes, right? So when we add this angle 1, 2, 3, when we add these three angles, we are getting what? A constant number, that is 180. So that is only the angle sum property of a triangle. That means the sum of the measures of three angles of a triangle is 180 degree. That is the angle sum property of a triangles. Okay, it's very simple. So when if consider any triangle, so if here it is 30, here it is 110, then what about this angle? Yeah, you said it, that is that should be 40. Why? The reason is that if this is 110 and this is 30, of course when we are adding these twos, we will get to what? We'll get 140. The sum of all angles should be 180, therefore it should be 40 degree, right? It is angle sum property of a triangle. Angle sum property of triangle means this much only. The sum of the measures of all these three angles should be 180. So hope you understood this much. Thank you.